Colleagues, ladies, friends and gentlemen, especially our guest of honour, Professor Wilson, welcome. It's my pleasure to introduce this evening's speaker on behalf of the Principal, who is in the United States on university business, but she sends her very best wishes for this evening's event. After a few words of introduction from myself, we shall hear Professor Wilson's inaugural professorial lecture. After the lecture, my colleague, the Assistant Vice Principal for Learning and Teaching, Professor Frank Muller, will give a vote of thanks, and then we invite all of you to please join us for drinks in Lower College Hall. This is only our second in-person inaugural lecture after 2 years of online events, and it still feels particularly enjoyable to see so many of you here with us. We are all delighted that Professor Wilson is helping us to return to those university occasions that were so important to our community and such a joy to all of us. Professor Robert, or Rob, Wilson, of the School of Earth and Environmental Sciences earned his BSc in Geology from Durham University and his MSc and PhD from the University of Western Ontario in Canada, having also gained a graduate honours diploma from the Institute of Antarctic and Southern Ocean Studies in Tasmania. He has held technical, research and broader academic posts in Tasmania, Canada, Germany and Scotland, and he arrived from Canada in 2003 to a research fellowship at the Grant Institute in Edinburgh. He joined us at St Andrews as a lecturer in physical geography in 2007 and was promoted in 2011, 2016 and in 2019 when he became a professor. He retains many international connections throughout his work, not least with the Lamont Doherty Earth Observatory at Columbia University, where he holds the position of Adjunct Research Fellow. Professor Wilson's research focuses on the late Holocene paleoclimatology using dendrochronology, which is meant, expressed in my deeply basic terms, that he studies tree rings to understand what produces climate and environmental change. So despite his original specialism in geology, scientifically, the study of ancient and modern trees has taken Professor Wilson way beyond his early training. This might make him seem an unusual fit for a School of Earth Sciences, but in fact, he fits exceptionally well within a large group trying to understand how the climate has changed in the past. His archive is certainly very particular, but he is using it to answer the same scientific questions as many of his colleagues. At the core of Professor Wilson's research has been a long-term study to reconstruct the northern hemispheric summer temperatures over the past few thousand years at exceptionally high thermal and temporal resolution. He has built into such work a focus on ecological problems of human disturbance, including pollution impacts, management and timber cutting, carbon sequestration, and methodological development, as well as archaeological dating. Beyond this, he has performed fieldwork in many regions of the world, from Europe, Western and Eastern Northern America, to Tasmania, Argentina, and Malawi, each area building at a higher resolution a record of climate around the globe. Beyond his research, Professor Wilson's exceptional intellectual breadth and versatility are shown as a valued teacher, and he has also been a first-class director of teaching ever since 2017 and throughout, of course, the last 2 punishing years. He has been working hard on the new Joint Earth Sciences Geography degree and has been responsible for various other activities that are appreciated by students and colleagues alike, such as an honours advisor and admissions officer. His head of school points out that Professor Wilson is one of those people who just makes things happen. If he has an idea, he sees it through, and he brings others with him thanks to his flexibility, determination, and patience. When he is not teaching or conducting research, I am told that Rob is one of those very strange people who run up and down hills for enjoyment. Apparently, energetic would be an understatement. And alongside his well-known passion for running up and down hills, he additionally has a famous penchant for data, graphs, statistics, and spreadsheets so large and complex that many of them have their own national anthem. And of course, he likes to combine these interests into data, graphs, stats, and spreadsheets of his running and his cycling. Each of his runs is fully recorded, analysed, and graphed. Since the lockdown of 2020, Rob has run 3,047.59 kilometres with 106,124 metres of elevation gain. And he has cycled 8,803.23 kilometres with 97,958 metres of elevation gain, just in case anybody was wondering. That being the case, it's a complete wonder that Professor Wilson has found the time to write and present this evening's inaugural lecture, but we're very grateful that he has. His evocative title is Serendipity and Arboreal Happiness. Please join me in welcoming him now.
Well, she's already given my talk. Okay, yes, I've been 3 years almost since I got promoted, so it was a bit weird having all of that time to slowly think about how to do such a talk. And I thought I'd come at this more with regards to the journey of where I started and how I got here, because the process hasn't really been planned in any way. So any time these guys are talking about strategic plans, I just know that it's never going to work out, because the more interesting things in life are always the random events. So this is what my talk's really building on. So, okay, this is all just a repeat. So, thanks to Claire because I always talk over time. So, I can rush through this now. So, yes, I'm a tree ring scientist. I use tree rings to study both past environmental change, past climate change. And if people ask me what I am, I usually just say I'm a paleoclimatologist. And really, hopefully from today's talk is I'm not going to fixate so much on the research I've been involved with, although I will touch on, of course, some of the sort of the key points or the key moments I've done over the last 15, 20 years or so. I kind of want to give an idea that actually a lot of the good things that came out of this came from random events that I had no control on, right? It was making the most of those sort of serendipitous events and so forth. So, very briefly, I'm going to just give you a little bit of a background, although Claire's kind of given that already, so she's kind of given some of the game away, but I will give you a slightly different nuance on the whole thing. They're basically where I started from and what my initial interests were, interactions with people, and then how we kind of lost control with life for a while and then slowly got back on track. Then I'll dip into my research with regards to my main focus of trying to study large-scale climate change. But interrelated with all of that is interactions with many scientists, and certainly a decade or so ago, climate skeptics, and all the stress that was involved in that period, but then how I used all of that to sort of learn to better my sort of approach to scientific communication. And then, because a lot of what I do is quite global in nature, I have been lucky enough to travel to many locations, right, global impact and so forth, but there is this, and this is very much a new thing on all our agenda with regards to our personal carbon footprints, and I'm definitely one of the guilty guys. And then I'm going to finish off with kind of maybe a little bit contentious, but sort of my viewpoint about modern academia and how the initial passions that got us into research maybe kind of been squeezed out a little bit. And then I want to finish off on a more, it's all positive, try not to be, but I'll finish off on my tips for surviving academia. These are my personal tips for all the students and colleagues around. You may not agree with all of them, but... So, how did I get here? So, let's start right back at high school, and there's a reason for this. So, I went to a boarding school on the border between Cumbria and Yorkshire, Sedbergh School. Some may have heard of it. Now, this is a sport-obsessed school. So, I was brainwashed from a 14-year-old. It's nothing to do with me. And if you see my family, they don't move, right? It's not genetic in any way. So, it's nature versus, and all that kind of stuff. And we had rugby, cricket, the whole thing, and fell running was forced upon us. We were surrounded by hills. Often as a punishment, we would have to go and climb the local hill in the morning before breakfast, and they would be monitored by the teachers who would be running behind us. So that was my life. However, at this time, there was a wonderful geography teacher who every summer went traveling around the world. And then he never taught us anything except give us slideshows about the Himalayas and Canada and Patagonia. And I got this passion for physical geography. And I should say, as a geography teacher, he was awful at human geography. He hated teaching the human geography. So we all came out with this beautiful physical geography knowledge and knew nothing about social science at all. Nothing against any social scientists. And not long after I left school, he then started an A-level in geology and then forgot about geography. So a lot of my drive is because I have a love for mountains, basically, and glaciology and what's involved in all of that. So, as Claire said, I did a BSc in geology. I like to say I failed, and I'm quite proud of the fact that I almost failed, not quite, I got a 2-2. Clearly rocks were not for me, and in the English system, it's pretty fixed, so you had to restart the whole degree, so that wasn't going to be a case. So I got my 2-2, rocks weren't for me, but the good news is that I did get a first-class degree in kayaking and kayak instructing, and I spent many summers teaching as a kayak instructor down in the Lake District, and it was a very wonderful time. Then in 1993, I decided to try to sort of 6 months later, after sort of swanning around and being a kayak instructor, I basically applied around the world, and I thought, well, glaciology is for me. And I managed to get a little bit of funding to do a 2-year master's in Tasmania at the Institute of Southern Ocean Studies and Antarctic Science. And I get there and I failed the medical. Now, I honestly did say to the doctor who failed me, I said, look, if we go for a run and whoever gets first back can make the decision, they wouldn't have it. They seemed to think that if I put a penguin in my face, I was going to have some anaphylactic fit and wouldn't be able to do it. So their response to all of this was then to degrade this 2-year master's to a 1-year graduate diploma, which was fine because I had then lots of bit more money. And they sent me off into the Tasmanian wilderness for 1 year to do glaciological mapping of the last glaciation, really the deglaciation period. Now, if anyone knows or ever been lucky enough to be into Tasmania, a third of that island is complete wilderness. So rather than being at some nice plush station in Antarctica where there would be, all the kit and everything they needed, I was there in a hut with my future wife at the time and so forth, with nothing, no support, just food. And it was in many respects, it was wonderful, but also disastrous because a lot of field work was in the winter. So that was me. So this is a picture of my actual field area at the time. It was an 8-hour hike in from the nearest gravel road to get there. Just off here is Pelion Plains. There's a hut here. There's actually an 8-day walking track that comes through the wilderness here. And we just stayed in this hut with a little potbelly stove. Walked in, I think, 4 times. And I show this only because, just to give you an idea of maybe potentially, I didn't even know. I didn't want to be an academic. That was never my plan, to be honest. But at the end of this, I did write my first paper, right? I had no clue about academia and what was involved. And it's a pretty awful paper. Please don't dig it out. But it's in the Royal Society Proceedings, the Royal Society of Tasmania, and it's all of this. I think it's really hard to find a PDF from things so old. But this is the direction we're looking here, Lake Eyre Valley, and you can see all these retreat moraines that we were mapping at the end of the last glaciation. But it did give me that early taste about what research would be.
Rob, can you turn the lights down?
I can try. The cameraman might be unhappy. Is that better? I guess the cameraman's not there to complain. So there you go. If you want the PDF, I can send it. No, I'm just joking. Now, so up to now, I was sort of getting back on track. I thought glaciology was going to be my thing. Everything changed in Tasmania. So this is where this whole concept of serendipity comes in, random events coming up. And every time I tried to make a plan, everything derailed. Often for the better, but you had to work at it to make that. So, unplanned random event 1. I met my now wife, Andrea. We were 2 of 3 Caucasian overseas students. The rest were Fijian, Asians, and so forth. So, of course, we all gravitated together. And next year, we celebrate 30 years together. And we've had a wonderful life, not only doing all the adventurous things that we do. She's slightly more broken than I am. She had a hip replacement 3 years ago, but apparently it's my fault for dragging her out with her. But we have both elevated up the academic ladder together. She's based at Edinburgh. She got her PhD 1 year ahead of me. She got professorship 1 year ahead of me. She's 10 days older than me, so that must mean she's slightly more intelligent, I guess. But I think we've balanced life pretty well in our academic careers. She would complain I don't do enough housework, but I do all the gadgets. Unplanned random event 2, with regards to my academic life, perhaps is more important, is while I was in Tasmania, I met my first dendrochronologists. Brendan Buckley, at the time, was 35, and he was doing a PhD at the same institute I was at. And he gave a talk one day, and he showed some of his early treeing data from Tasmania, and then just had a simple plot comparing his Tasmanian treeing data and then an ice core record from Antarctica. And they kind of showed the same thing, and I just thought, this is amazing. How is that possible? Right? Now, of course, 30 years later, it's the Antarctic multi-decadal oscillation and how that interacts between Antarctic and the Southern Ocean. But at the time, I just thought, well, how is this possible that a tree in Tasmania and an ice core in Canada, in Antarctica could kind of show the same thing? Now, his supervisor, Ed Cook, he's the director of the treeing lab at Lamont Doherty Earth Observatory in Columbia University. Right? Just happens to be the guru in my whole field. And I met him, and I just thought at the time he was some old guy who was shuffling around the time. And actually, now back, I am now older than he was back then when I first met him. And he always had a big beard, and I thought him as an ancient old duffer. However, these guys have been a fundamental part of my whole academic life. You know, the later adjunct position with Columbia University just came from the interactions I had with him. I can see my tech in the room. He's been on emails with these two guys this last day, and we just have this wonderful banter. So the reality is that I went to Tasmania to do glaciology, and then by the end of this process, at the end of my degree, I then shifted to tree rings. They offered me an initial 12-month contract to be a technician at the institute in Tasmania to do tree ring science, and then with a plan that I would then go to New York, to Columbia, about 12 months later, and then take up a more permanent technician position there. That was the plan in 1994. This happened. So our holiday romance, told you I'd embarrass you. Our little holiday romance went, basically, long story short, contraception doesn't work in the tropics. We had a last holiday together in Indonesia. And this is probably the most disastrous, nice thing to have happened to both of us probably for the last 30 years. And our son was born in 1994. But then this completely derailed the whole process, right? I thought, I'm going to go to New York, going to do all of this. Not going to happen. So I could do nothing else but to move to Germany, right? Andrea was still in the middle of a Diplomarbeit, like a master's, like an integrated master's. And so I moved to Germany, and while she was finishing her master's, I very early on got this job as a geologist for a building company, a Baugrund Institute, and hated every minute of it. Every minute for 3 years I worked for this job. Started off 5 days a week at the beginning, and by the time we left, I was down to 2 days. And because I was earning quite a bit of money there, because we weren't paying tax, but we won't talk about that. But because I was earning this money, and because of the collapse of the Soviet Union, all of this tech was coming over from Russia into the flea markets in Germany. So I set myself up as a treeing lab. I brought a microscope. It's even got CCCP on it. It's in the treeing lab if you want to see it. The whole work. I mean, that's a museum piece now with regards to everything. And so I built up myself a little treeing lab, bought myself a stage. I flew over to New York, brought my, just what else are you going to do with your money when you've got a little child? There's nothing else to do. And then I did historical dating. So I started dating buildings in southern Germany, in Bavaria. Columbia would then send me samples, and then I would just earn money by contractually and slowly building up data. And then these buildings later actually became the data set for my PhD. Now, again, in all of the stats lectures I teach, I always talk about research design. You must have a hypothesis and all this kind of stuff. This was all random sampling every building and every tree I could see. There was no plan, absolutely no plan, but I could not have chosen the best place in the whole of Germany to find moisture-limited trees to come up with a later hydroclimate reconstruction for precipitation and so forth. So, again, serendipity. Look. So, slowly getting back on track. Back to academia. When Andrea finished her diploma bike, we were busy applying all over the place. We both had pretty much decided that staying in Germany wasn't the thing to do. So we both managed to get positions or PhD positions or master's positions in Canada. So I initially moved out to do a master's because the one-year diploma from Tasmania wasn't good enough to do a PhD. So I did a 2-year master's. Andrea went straight into her PhD. And then I stayed there, did a PhD. So British Columbia was the area of choice for my master's. I have to say this now because that date, 1999, is quite important. So I was doing a temperature reconstruction from Western Canada, British Columbia. And then for my PhD, I kind of annoyed my supervisor because I refused to do the same project. He basically just wanted me removed from British Columbia to the Yukon. And now Emily, she's in the audience, she's now doing my PhD from what should have been from 20 years ago. And then I just thought, I was sitting on all this beautiful data from Germany. So I continued that work. And then with Andrea getting her PhD a year before me, we returned to the UK in 2002, which meant that I had a whole year without my supervisor to finish writing up my PhD. It was a wonderful period. I could email him the chapters, and then he had no choice but to type in all the comments. But before, it was all like red ink everywhere. And that really facilitated that last year of the PhD write-up. Then I was really lucky anyway. Andrea had a job at that time before she got a position at the university. So she was working for industry initially. And then I went through that sort of 3 or 4 year period at Edinburgh where I had multiple short-term contract type postdocs. I was also doing the contractual work with Columbia University. But it kept us going quite nicely for that period and gained a lot of experience that ultimately helped for later. Columbia gave me the adjunct position in 2006, which I've retained since, and then finally I got the permanent position at St Andrews in 2007. That was a wonderful moment to get that permanent position, I must say this, because up until then you're kind of not in control of what you do. Although the Columbia lot were pretty relaxed with regards to me writing the odd paper in whatever little whim I had for that month. But ultimately, once you get here and you get that permanent position, all of a sudden you can do what you want. And you know, for anyone who's going into academia, you know, that's the vision, right? That's the creativity where you can do kind of anything you want. It's beautiful. Now, I never made it to Antarctica, and I had to put this in because this is the closest I ever got. So this is doing field work in, well, there's not a lot of trees in the picture, but we were doing field work in Alaska. This is the Harding ice field. So this is as close to the feeling, I think, of just being in Antarctica that you could get. Yeah, I just had to put that in just for the sake that I will never go to Antarctica. There's no trees there, and I will never go as a tourist. And until some trees start growing on the West Antarctic Peninsula, not going to happen. Okay, so that's my life, just to give you a bit more of the background of how I got here. Okay, let's get into the whole research aspect and the evolution of my career with regards to that. Now, the bulk of the work, I think, that's really sort of got me here today is really my work on climate change, mostly temperature, although I've worked with sort of precipitation and climatic changes. Now, we all know, nothing new here. This is particularly relevant for this week, right? The IPCC, the Intergovernmental Panel on Climate Change, a global warming of 1.5 degrees from pre-industrial levels will lead to irreversible effects on our climate system and substantial impacts on human society. And the third part of the latest AR6, or the 6th assessment report, came out this week. And I don't know if you've been seeing the sort of press releases, you know, we've not got a lot of time to try to turn things around with regards to carbon in the atmosphere and so forth. But to get to this point, right, where there is generally an acceptance of the science, has required not just me, but many scientists to keep pushing and keep pushing to build actual data that would agree with the theory from the 70s and even earlier theories to get to the point where there was some degree of acceptance. So it's a bit washed out in this thing, but this is just a plot of purposely a bit different. So this 1.5 degrees here is based on annual temperatures for the globe, at sea surface temperatures and terrestrial temperatures. This is northern hemisphere summer temperatures because that's what the trees represent, right? They're growing on land, they grow in the summer. So that plot of instrumental data for global annual temperature anomalies from 1880 to present really highlights that warming trend. But if you just look at the terrestrial thing, we're already, if you're comparing the coldest decade and the warmest decade, and this is not even pre-industrial, it's already over 1.5 degrees if we just focus on the terrestrial temperatures. So a lot of my research has really been trying to extend that data set back in time, because the further back we go, the more we have a richer flavor or flavors of what's driving climate for different periods. And we really need to understand those drivers in the past and also understand the drivers in the recent period so we kind of know what may happen in the future. So that's been my life. Most of it for the last 20 years is trying to understand that and reconstruct that back in time. It's not just a temporal question, however. There is a spatial element. So this is basically the most recent decade as a spatial anomaly map compared to the mean from 1880 to 1980. And we could see that over space, then the rate of change of that, or the amount of warming of the most recent decade is not the same, is not homogeneous over space. So generally the change in the oceans is relatively slower, sometimes even almost no change or slight negative trends. But then you could go to Central Europe and the Alpine region and the warming is much greater than the average. So 2-degree warming in the Alps. So if you want to do your skiing, get it done now because those glaciers are disappearing fast. So to study climate change really is not just a temporal problem, it's a spatial issue, right? So we need to understand both aspects. And trees, so I hope you can read this because it barely can see it with this. It looked better on my computer screen. Yellow on blue is maybe not so good anymore. Trees are perfect for this, right? This is a map of the archived tree ring data sets from the International Tree Ring Data Bank. And you can see there's absolutely loads of data in the northern hemisphere, not so much in the southern hemisphere because there's not a lot of land. Very little in the tropics because trees grow all the time and it's really hard to work with the sort of traditional methodologies that we do. So the dating of tree rings, we can extend these data sets back in time so we can sample living trees. We have a barcode of thin and wide rings. We can sample timbers from buildings, right, old buildings or ancient buildings, and then we can also maybe find preserved material of the same species in lake sediments, river gravels and so forth. And we theoretically can build long chronologies going back for however long the material is preserved. So in Scotland, we have a continuous Scots pine chronology for over 1,000 years, but we've got material going back 8,000 years. In Central Europe, the long oak chronology goes back continuously for 10,000 years, right? So these are really important archives at annual, exactly dated scale. And that exact dating is important as we go forward with this story. And then there's also, when they're sampled in appropriate locations, meaning you need to go for temperature to some sort of temperature-limited situation, like an upper tree line in the mountains, or high-latitude environments in the high boreal forests, then you get a strong climate signal. Just like with rocks, there you go, it's the only mention of rocks in the whole lecture. Just like with geology, trees, we can measure a variety of different parameters, okay? We can measure the ring width, we can measure wood density, dreaded isotopes, and we can even go to the fine scale, wood anatomical levels, right down to the cellular level, measuring, I don't know, cell wall thickness and so forth. So it's an incredibly rich amount of data that we can measure from these type of archives, but they go from relatively cheap to extremely expensive, right? And when I say that, we could probably set up a simple lab with a scanner, a sander and so forth, £1,000, boom. And you could do quite a lot of dendro analysis that way. And you go down here and you're getting past the isotopes into the wood anatomy, and then you're looking at £100,000, right? Or more, depending on the size of the lab. If you're in WSL, if you're in Switzerland, it would be even more than that. Now, wood density has been kind of the primary parameter that I've worked with. When sampled, when measured from the right trees in the right location, provides a really robust estimate of past summer temperatures. But an X-ray densitometer is £100,000, give or take. And when I came here in 2007, it was very clear, very quickly, that the university wasn't going to buy me a densitometer for £100,000 because there was no one else in the university that would need it. And no matter how many economic plans I could put together, it wasn't ever going to happen. So me being me, I thought, well, who needs density? There are better ways. Or different ways. So when you actually look at wood, and this is just a single ring of wood here. You have these larger cells in the early part of the ring at the beginning of the year, and they steadily get thicker and denser as you get to the end of the growth ring. So the density, that yellow line here, starts low and then increases into so-called late wood here. And then if you think about it, even you can see it, it starts from basically light colour wood to darker wood. So if you just measure the change in the light intensity through a ring, right, and measure the amount of darkness, then you actually have a proxy of the wood density. Okay? So there were some papers in the noughties that came up with this concept, but no one really did anything with it, and I came to St Andrews, I didn't get my densitometer, and so I then contacted a colleague in Sweden and said, well, can we incorporate this into your software? They had some image analysis software. Can we somehow measure this blue intensity measure? And he initially told me, no, who's going to pay me to do this? And I said, well, I don't know. And then 2 weeks later, he sent me a beta version with a concept. And then through 2009 through to about 2011, through some technicians and through a PhD student later on, we then explored it. We developed the software. It is still today $68, right? There is another piece of software that another group have developed that does exactly the same thing. It's $10,000, right? So since about 2016, 2017, I've been running with a colleague in Poland annual workshops, pushing this methodology. This is just a spatial map now of all the publications that have come through the years, and then this is the number of publications. So this method is really sort of hitting the zeitgeist within the community, because it's not just a method for 5 labs around the planet that have a densitometer. It is literally a method for the masses. It's my sort of communist method, my socialist approach to measuring ring density, the democratization of wood density. And now it's just beautiful, because one of the problems we have is that for really improving our reconstructions, we need lots of data from lots of locations, and no single lab can really do that effectively. So now, it's a method for the masses. So last year, slightly delayed because of COVID, but we decided to start it up last April. We created this new consortium. This consortium has over 100 participants from Bhutan to Alaska. And already within this, we've got 70 papers published since the beginning, since the noughties, but most of them in the recent period. So I'm pretty proud, if nothing else, with the fact of this. Now, it is a cheap method, so when it gets to precision, there are huge issues. But the whole point of this consortium is how can we improve the precision, but by keeping it cheap, right? That's our sort of driving thing with this whole methodological approach. Okay, so trees are wonderful things, right? That's a quote actually from a colleague down in Swansea. It's in one of his papers, right? But basically trees, the growth of trees and all those parameters that we measure from them, they give us some representation of how that tree is responding to the environment that they're growing in. So for my interest's sake, that hopefully there's some sort of climate signal in those archives, whether we're looking at ring width or density and so forth. Now, it could be temperature, it could be precipitation. That really depends on where we're sampling. There might be, and I've used the D here in a sort of biological sense of just disturbance, right? So that could be ecological effects. You might have a tree dying because of a lightning strike. That will then impact the surrounding trees to a certain degree. And then you've got these stand-wide effects that could be tree disease, pollution, insect attack, basically ecological issues, right? So my signal is climate, but the ecologist, the signal would be these disturbances, and then the climate would be their noise, right? So we will have this thing. But this opens up dendrochronology to all sorts of disciplines, whether you're trying to do glaciology or ecology and so forth. So it is a wonderful, wonderful diverse discipline because of that. So my raison d'etre is to reconstruct climate, always has been. That's my primary goal. I only touch on ecological and all those other issues because they're almost secondary, and then sometimes you just can't ignore them, right? Sometimes you annoyingly have to understand timber extraction in Scotland for the last 500 years because the trees are doing some crazy stuff which are clearly not climatic. So you've got to try to model that, remove that signal, and then what you're left with is hopefully the climate signal, right? So for the rest of this, I'm going to talk on just the temperature story. I'm not going to go into all the nuance and the detail. But, just be aware that I've been involved with sorts of ecological studies. I'm now being slowly more and more wrapped into the carbon sequestration. But we're essentially too late because we should have been planting the trees 50 years ago. So we need to plant a lot of trees. And even then, it's only a small amount of carbon. But anyway, that's another thing. Okay, random events. Purposely, so this is really a period when I was kind of, got my PhD or my master's and started my PhD, and life was pretty comfortable. And then I went into a period when I started interacting with some of my colleagues and the climate skeptics, where life became a little bit rocky and it sort of changed directions a little bit. So when I was doing my master's in British Columbia, and I finished my master's in 1999, and around the same time, a very well-renowned professor who's now in Penn State called Michael Mann produced this reconstruction of Northern Hemisphere temperatures. It was the first attempt at quantifying Northern Hemisphere temperature reconstructions, and the basic conclusions hold up today, right? Now, it was hugely influential in the third assessment report, the IPCC, okay, in 2001, and the climate skeptics absolutely detested it, right? Now, Mike Mann, he's very well respected, lead author on the IPC in 2001, 2007. He's got all sorts of medals from every organisation you can think of, you know, Bloomberg's list of 50 most influential people on the planet and all this kind of stuff. And it is very well known in our discipline that Mike and I don't get on at all. And I put him here, and I placed this here because I know some of the students here have seen my lectures, and they always feedback in the lectures, oh, that was a great lecture. Rob spent 3 hours trashing this guy. But I am here today because of the indirect and the direct interactions I've had with him or his work. I have to mention it because if I had just been a little mouse doing my own little thing in Northwest North America and not addressed some of the crazy stuff that he's trying to do, then, you know, the world would have been in a worse state. I'm not saying that everything he's done is bad, but me and the community have had to really respond to some slightly bizarre situations. But first, initially, let's just go back to 2001, right? So 2001 was the third assessment of IPC report. The hockey stick dominated that report. And that was kind of the early days of the internet, early-ish. Certainly the blogs started coming up as web pages, right? It's people interacting, everyone had an opinion, you know, and I've got my thing or whatever, right? So there were many skeptic-based blogs, there was a few consensus blogs and so forth. And what I couldn't understand in this period around 2001 is initially I couldn't understand why there was so much anger towards this study by Mike Mann. I couldn't understand it in the early days. And, you know, certainly in hindsight, this initial study is not perfect, right? There's a lot of flaws and you could easily pick holes in it. But it was the first attempt to do something very complex, both for temporal resolution and he even did a spatial reconstruction for the globe, or at least the Northern Hemisphere. So this was the period when I was doing my PhD and into my postdoc, so 2001, 2007, a period when you have so much time. So much time, there's no admin, you can do anything you want, and you can spend hours responding on blogs. Honestly, it's a beautiful period in life. If you're going to get your postdocs to stay as a postdoc for as long as possible, keep away from any of these guys, right? It just, they make life difficult, right? So, right up to 2016, I constantly interacted with these blogs, much less latterly, and I tried really hard to go onto these blogs and try to rebut these pretty poorly informed statements. And I can guarantee most of the time it ended in more tears at my end because I got so frustrated, and then I often got very angry, and then I would say something kind of flippant. If anyone knows my sense of humor, I would generally say something, if you know me, you would have taken it as a joke. But if you don't know me and it's the other end of the, you know, and I would just, it's like putting a grenade in there, right? So out of all of this period, the one thing I learned from this was that, and one thing I don't think you ever appreciate in the early days of your academic career, is that you're not just writing a paper for your peers and the people around you. Other people are going to read it. And maybe even the general public will read it, and they may not agree. They may have a different opinion, right? They might be wrong, they might not be as informed, but you need to appreciate that that might happen, and then you need to understand why they have that response to the work you've done, right? So this whole period was really illuminating for me that it was, just because it was written and peer-reviewed, it didn't mean that everyone would accept it. And I don't think a lot of people realize that early on in their career, right? So I now never write a paper. We're all skeptical as scientists, but I'm an uber skeptic now when I write my own papers because I always just really don't want to get sucked into all of this criticism that can often happen. So you're always second guessing what these skeptics could or could not do. So, building on Mike Mann's work in 1991 and the AR and the third assessment report, a whole bunch of different groups around the world, and whether it be NOAA, the Swiss, North Americans and so forth, started working on this problem of doing Northern Hemisphere reconstructions, getting new data, basically trying to improve on Mike Mann's original work. Roseanne Dorigo, another colleague of Ed and Brendan's at the Columbia University, we started collaborating through this period very intensely, and it was the perfect period, because she wrote the proposals, she got the money, I did all the analysis, and then we wrote the papers up together, right? And when I actually applied for my job here, at the panel, they asked me, can you lead science? And I said, well, I think I can. And they said, well, yeah, but you haven't got any money the last 5 years because you've been relying on this. And I said, well, wouldn't you if someone was actually writing the proposals and you could do the science? And they seemed to like that answer. So that was my period at the time. So anyway, out of all of this, all of these different groups, by the time we get to the fourth assessment report, we had a whole spaghetti plot of different variant of Northern Hemisphere reconstructions. The one I was involved with, or one I put together, was down here, sort of at the bottom end of the whole thing. Okay? A slightly more honest rendition, I guess, of the uncertainties with our understanding of Northern Hemisphere reconstructions. Yes, they all show the warming, but the amplitude of cooling through the so-called Little Ice Age here was quite different, and then the medieval sort of existed and so forth. But it was, in a statistical sense, a big improvement, was far from perfect. Just to give you I need to set the stage here. This blue line is our reconstruction in 2006. The pink line is just a model mean of a whole bunch of models. Something you should never do. I should show the whole ensemble, but it was just the model mean at the time. But back to around the 15th century, the agreement between the tree ring-based reconstruction and the models was pretty good, actually. You know, the cooling periods we knew were related to volcanic events. We have anthropogenic warming in the recent period, and then the impact of the solar effect was relatively minimal. But when we go further back in time at that time, then the agreement was pretty awful, right? So coming out of that sort of 2006 work and the AR4 model, all our emphasis of work as a community, it wasn't just us, was to basically say, well, it must be the tree ring data, it must be the paleo data, we need more data, right? And we really did. We only had 6 tree ring records that went back to the medieval, and when you're doing the Northern Hemisphere, that's clearly not enough. So that's what we were all focusing on. We were creating more data sets, trying to go back to before 1000 AD. And then the next unplanned event happened in this period. When we were all focusing on one aspect, then our friend little Mike Mann comes along and then just blows the community up by basically trashing the whole of tree rings and saying that they can't do temperature reconstructions for the last millennium, even though he'd already done that almost a decade before. The details don't really matter, but to labour this, for me personally, the one reconstruction he was using to trash them, or with regards to the modelling, was the one I had developed with Roseanne Dorigo. So we were automatically sucked into this whole debate because it was our data that he was criticising. So Kevin Angikaitis, very good friend and colleague from Arizona, University of Arizona. We basically, it started off as a conversation. What do we do when we started emailing our colleagues? You know, this paper clearly had never been reviewed by any dendrochronologist, right? It would never have been accepted in any normal reviewing process. So we had to write a response. So we contacted all the different groups as best as we could who had been working on Northern Hemisphere reconstructions for the last sort of 5 years or decade or so. And we basically, all of us, went back to our raw data, tried to reevaluate it. We tried to think, well, is it possible we made a mistake? No, that wasn't possible. And so we then tried to rebut it. And we had so much material that we wrote an initial short response, okay, which was delayed because Mike Mann was busy on a book tour, I might add, just to give you the context here. But then the nice thing about all of this, which really is when I'm talking about this sort of our response to Mike Mann, was this opened up a whole new period of wonderful collaboration because it forced us all back together. Rather than different groups working, we all came together, right? And then we were coming up with a plan, and so multiple papers came out over the next 5 years. I don't need to detail with them, but the important thing is a new global collaboration came out of this, and because Kevin and I were then really the leaders of the initial response, we gravitated and we started leading what then evolved into one of these other consortiums. So it became NTREND, Northern Hemisphere Tree Ring Ensemble Network Development Consortium, real mouthful. But we then were focusing on trying to come up with a quality extended, expanded network of temperature-sensitive archives to come up with a better reconstruction for Northern Hemisphere temperatures. And Kevin and I have basically agreed that I would do the temporal story and then he would do the spatial story. So this was the new reconstruction that came out of N-Trend, and I would say there were still a couple of other groups who are now in trend now, but they were still doing similar reconstructions. And you can see that, we can see the warming in the period and so forth. Now, if you actually put this on top of Mike Mann's original hockey stick, the basic shape is the same. I think we've got a slightly more amplitude. We've got a medieval here, but you can see it's quite erratic. But we've got a much richer data set here, and that whole criticism that tree rings couldn't pick up volcanoes that in his 2012 paper, well, let's put up the major volcanic events from the tropics and so forth. So, we knew this all the time, but, he had misused a data set. That was his crime, and then did not accept that he had made a poor choice in his approach. So, just to give you some of Kevin's results, here is this is the instrumental data for the Krakatoa spatial reconstruction. So Krakatoa blew its top in 1883. This is 1884 spatial, so you can see the cooling. That's what the tree ring data give, so the spatial pattern is pretty much the same. We can go further back in time. This is the year without a summer in 1816 as a result to Tambora in the warm pool region blowing its top in 1815. So the trees really do pick up the volcanoes. We knew that. Mike Mann, unfortunately, was wrong, but it led actually to this beautiful collaboration that's ongoing today. In fact, Kevin is coming here in about a month or so with his partner, and if you want to cobble some two good scientists, then they're the people to get. So why am I talking about volcanic footprint, as well as just part of my sort of backstory here? This is, before I was showing you Northern Hemisphere reconstructions, it's slightly washed out, but this is the reconstruction for Scotland. Temperatures only going back 500, it actually goes back to 1200. Look how miserable it was in the 17th century here. On average, it was 1 degree cooler than the recent period, a prolonged, miserable period to be Scottish. But if we zoom into the end of the 17th century, then I put this in just to sort of give you an idea of some sort of societal response here. So this was a sort of cheeky little paper. The only time I've ever tried to be political in my science was we wrote this paper, Complexity and Crisis, how Scotland couldn't cope and all of this, and trying to get Dan Clayton from geography involved because we needed someone who had some historical thing. In the end, we had to get some other historians. But this period, it's the coldest decade for the last 750 years in Scotland, at least for summer temperatures. It's well known as a period of dire strife in Scotland. The ills are there, 7 multiple famines over this period. At the same time, Scotland decided that they were going to set up a colony down in the Panama, the Darien expedition that went horribly, horribly wrong. All of it going together, crippling the economy, famine, the agricultural collapse and so forth. And it is not a fluke that the union with England happened a few years after this, because basically Scotland was brought to it. It had no choice at that time. And I'm not doing the paper any justice. It has a lot of detail, but it was a really nice story. But we, at the end, just read the last paragraph, because we tried to write this paper, and we were talking about smaller states being more resilient as part of a wider economic union. We called it the Brexit paper. The problem was the Scotsman took it and then was thinking it in terms of independence, and then went completely off on track. I can see they were understanding. But anyway, so these volcanic events can cause cooling that can cause an impact on society. That's just and you could give lots and lots of examples about that. But it's complex, right? There's lots of geopolitical aspects that you need to keep in mind with all of these kind of games, and it's not just a simple environmental deterministic issue. But why should we care? We're in a warming world now, right? Why do we care about a cooling event that might be related to volcanoes? So, well, since Frank and I were born, carbon dioxide levels have risen by about 100 parts per million in 1970, okay? There is no evidence that there is a slowdown, right? So, and remember, the science is over a century old. The early models in the 70s were predicting warming, right? There's nothing new with what we're hearing at the moment, and we're constantly pushing it as scientists. But we are at this sort of crux point now, that if this political situation and mitigation of trying to reduce carbon in our atmosphere doesn't work, we're just going to go to some horrible part. It's going to not be a nice place to be living in the coming decades. So you've already seen this reconstruction, and we know, we have all of these beautiful examples of cooling with regards to volcanic events. We're not there yet, but the reality is if current mitigation strategies and carbon reduction strategies and all the crazy geochemistry stuff that we could do, that we talk about, all the third years just gone for the carbon capture module this semester, the news ultimately wasn't that good, right? And we're basically talking about a decade. We've got to do this within a decade, right? And nothing is at scale to do anything of any significance as we speak today, right? So there is going to be a point in the coming decades that we're going to have to start thinking about really radical solutions to the problem, right? So putting aerosols into the stratosphere, we know can cause cooling. Andrea Burke's work with regards to understanding the magnitude, the height of the plume, the location of these volcanic events, modeling work like Mike's doing with regards to actually trying to understand how the climate system could respond to that kind of perturbation to the system. We force it. We don't want to do this, but we're actually almost potentially going to be forced to do that at some point if something radical doesn't happen soon. So this is where this sort of global collaboration is really fundamentally important. From a science point of view, whether it's the N-Trend or the iBind stuff that I'm involved with, it's the only way to do the science at the scale. You can't just rely on single groups. We've all got to work together. And that's working pretty well, right? Earth science, okay? Bit of a plug for the school, but we are at the coalface with regards to whether it's understanding the climate dynamics or trying to reconstruct back in time or trying to understand the geochemistry of some of the methods that could help with regards to carbon reduction in the atmosphere, right? Now, of course, we interact with the chemists and different disciplines doing all sorts. Everyone's got to start doing their part and really taking this seriously, right? The governments really have to do this, and I know it's really difficult now. What's happening in Central Europe at the moment is just going to deflect everything, but maybe the fact that we've got to move away from hydrocarbon just because of Russia's going mad is actually the impetus that we all need to go to something that's alternative, right? Clearly, current policies are not really working yet, right? We can see that with the COP26 provided some optimism because finally, for the first time in 26 meetings, there was acceptance of the science, right? Which meaning I've done my bit now, I can retire. Given my talk, we've done our bit, there is acceptance. It doesn't matter what we're doing now, it's just we're refining the science, right? It's now the solutions that matter, really do. So that leads me to the whole issue of carbon and the carbon dilemmas of large-scale science, right? So just for kicks, I thought I would plot spatially the geography of my science since my first paper in 1995. So these dots are scaled roughly against the number of publications from these different regions. So of course in the UK I've done a lot of publications, lots and lots in Europe, Europe-wide syntheses with colleagues, Asia, mostly monsoonal dynamics. A lot of my Edinburgh postdoc work was in the tropics, working with coral data sets, and I didn't do any coral sampling, which was a real shame, but that was just the way it was. And then, of course, all the Northern Hemisphere work. Okay, so that's my geography of my published work. These are ongoing projects. I start looking at this and I start panicking because I wonder where, we've got projects that were delayed down in South America and so forth. This is a new project. This is an experimental project in a way because none of us are flying to Australasia or central things. We're actually trying to pay people there to do the sampling or to send the samples to us, which all sounds great on paper, but 6 months in, all the samples I've got for Tasmania and New Zealand have come from Columbia University and not from these things because they're too busy academics and they haven't got the time to send the samples. So, it's all very nice trying to do these sort of low carbon approaches, but it's going to be proving very difficult. And then these are all the locations I've done some form of tree ring fieldwork, let alone just going on holidays, right? So, this is clearly a sort of, a global thing. My carbon footprint's pretty bad. In 2018, and I'll never repeat this again, I lost control a little bit. Google Timeline said that I traveled around the planet 3 times that year, equivalent of. We're being scanned by every device we wear, right? And you get this email in January. This is what you did last year, right? So the last 2 years, I kind of counteract that. It didn't really go anywhere. Well, what is the answer? So this is really difficult, right? You kind of need to do this traveling to a certain degree to get the data and so forth. But yes, we could reduce travel. But to be honest, that's really, if you want to stay relevant, we need to do this work, right? The Southern Hemisphere is the big focus at the moment. For me personally, I found it a lot easier to get funding to go to other places than to get funding to do it in Scotland. If I could just stay in Scotland all my life and do 20 years of really detailed analysis and then other groups are doing similar without travelling, that surely would be the answer. But it doesn't work like that. It doesn't work. At the same time, the UKRI, the funding agencies, don't really allow us to pay people in other countries, right? So paying people in Australia, in Tasmania and New Zealand at the moment, well, the finance people have been very creative. That's all I'm going to say, right? So if you want to do impactful research that's a global thing, it's potentially going to have an impact on the very nature of the system you're trying to study, right? And of course, we're constantly pressured to be internationally relevant. So there is this sort of pressure from an academic point of view to be globally irrelevant, but then that's going to then lead to exacerbating the problem. So this gets me into maybe a bit of the contentious issue with regards to, what got me into academia in the first place, right? So it's passion, right? When Brendan gave that first talk and I talked about, oh my goodness, tree rings, this is my life. Honestly, from that point of view, I was focused like a torpedo, right? Academia is wonderful, right? And it's unique, I think, of any jobs. We get that permanent position. We can do any research we want within reason if we get the money to do it. We can also teach pretty much anything we want, right? It's a degree in earth and environmental science or geology. And then you imagine how big an umbrella that is, right? No other job is like that. My son works for Apple, right? But he has to do this one thing. And it's so secret, we don't know what he does, but that's what he does. So I still have this passion, I really do. But I do worry about academia now because certainly the last 2 years has been tough on everyone, but I do wonder if the pressures of academia now are starting to squeeze that passion for many people. Are we kind of losing sight of what got us here in the first place, to the point that we just go, is it worth the effort? So there's a squeeze. This is just my opinion, others might not agree, but I do believe we're all losing control a little bit, right? There is a constant increasing demand on our time. Constant. More research, more teaching, more admin. Added to this is that academia itself is competitive by nature, right? Right? There are expectations to write more papers, expectations to get more funding, right? We need to maximize the impact. Okay, that's fine. But at the same time, there's less and less money relative to an ever-expanding population of academics because there's more people going through the system. So it's getting harder for those people coming up from the lower levels to get that first permanent job. I don't see a simple solution here, right? And ultimately, how appealing is academia now for younger people? I'm not here to do as a downer, but I think we need to seriously think about these things as we go forward. So I do believe collectively, and this is not just for a school or a single university, I'm talking the wider academic community as a whole. Some sort of reset is needed, right? Easier said than done. But surely something can be done, right? I don't know if anyone has any Swedish colleagues, but any Swedish colleagues, they go on holiday for the whole summer. They disappear. It's a nightmare to work with them because you email them in the spring and you might get a response in September, right? But they have a really much better attitude to their science in my regard. And the reality is if we don't do something about this, it's not just the research that's going to suffer, the teaching's going to research because we're all just running around. So these are my 5 tips. So the whole talk is being built around this figure. When I found it. So everyone in the room can decide which of the hamsters. And I couldn't find a hamster that would just sit beside it, smoking a joint, looking up to it and saying, well, I don't have that problem, right? So, there's the one that's keeping up, or there's the one that's just bouncing around in the chaos. So, and I wish this cycle, because at some point this guy's going to get tired and then he's going to go, right? So these are my 5 personal tips, right? The first thing, be collegiate. It may sound obvious, but, be dependable as a colleague. We're all collaborating together. Answer emails quickly. It's simple to say that, but, I'm not looking at anyone. Make time for people. Not just the students, but for your colleagues and everyone. You know, we're all collaborating together. It's not just for science, it's for teaching. If we are collegiate in all of this and come together, it will work much better. Don't chase the research money, and I can see Tom here, but we get emails all the time. We've got 3 days for this deadline and all of this kind of stuff. My whole career, I've only really gone for projects mostly that I have really excited about. And you just can't run after every opportunity out there. And there is a lot of money potentially out there, but you've got to think about. At the moment, I've got several PhD students, and I've got all of these projects going along, and it does become to a point that's a little bit overwhelming because I can't add more to that, right? So we just got to be don't go for the money. Be humble, right? My interactions with Mike Mann is a very good example here. There's nothing humble about this guy at all, right? But he is one of many people I've worked with, and some people are just maybe. Just be a bit humble. We're not all brilliant at everything we do, and sometimes we make mistakes, right? But at the same time, don't be afraid to defend your corner, right? Right? We should all just stand down. There are processes for complaining about anything and so forth. Make time for your hobbies, right? How many weekends? For those of us in here, my wife and I, sometimes we get very frustrated. We want to go away for a weekend, and we go, I've got to mark. Just flush it down the toilet or whatever. It's just it's just the reality, right? And it's very hard. So finally, my last slide, and I've probably gone way over, and I apologise. Typical. Have fun. Don't take life too seriously. Have me more and more meetings. You need more jokes sometimes. We take meetings way too seriously, and on that, life will continue whatever happens. As one thing I've learned over the last 25 years or so is that there's these random events, but we've managed just to make the most of it. And life goes way quicker than we're going to think. I mean, I can't believe I'm 50-ish, right? So, thank you very much.
Dear guests, colleagues and friends, above all, dear Professor Wilson, it is my great pleasure to thank you on behalf of your audience and of the university for your contribution to our community and to your scholarly discipline, and especially for your lecture this evening. You've given us much to think about, and you did so in a characteristically energetic, lively, and engaging way. And who would not be grateful for such a bumper harvest of photos of the action hero researcher? Rob with a chainsaw, in shorts on top of a glacier, conquering some whitewater rapids in a tiny kayak, and fearlessly sporting hairstyles that today would barely get past the university's ethics committee. To be reminded how exciting, exhilarating, and literally horizon-widening the lived experience of an active researcher and teacher can be, should be, is a real inspiration. From the rich offering which you have provided us tonight, Rob, I'd like to pick out 2 points which have particularly impressed me. Your humane and encouraging observations on the coherence and structure, or the lack of both, in the development of your scholarly life, and the partnership you have struck with trees, who serve as your arboreal witnesses, whose own life records allow you to gain insights into the ancient history of our climate. So I'm afraid I may have picked up the 2 issues that most obviously appeal to me as a historian and biographer, but why not enjoy the perks of the job while you've got the rostrum? In an influential essay published in the 1980s, the French sociologist Pierre Bourdieu warned against what he called the biographical illusion. He critiqued the idea of life as a coherent and sequential story with a beginning and an end and a logical set of intervening steps. This kind of neat narrative of life and its sequential structure, says Bourdieu, is merely a myth of everyday life, the representation of a historically and socially constructed concept masquerading as a natural fact. Unlike Bourdieu, whose essay manages in just 6 pages to reach a level of impenetrability that can only be achieved by French theoreticians, Rob has made his central point very clear, that ideas of tidiness, controlled forward planning and sleek career design are somewhat unnatural and should not dishearten or discourage anyone embarking on a commitment to scholarship, inquiry, and intellectual curiosity. Detours, setbacks, and periods of disorientation should be embraced without trepidation as part of the human experience, and so should the manifestations of what Rob has called unplanned random events. Though I would naturally recommend embracing German life partners with particular warmth, bearded dendrochronologists also deserve a warm hug. Students and junior colleagues in the room should draw solace and optimism from what Rob has told us. If you've got a subject to be passionate about, not even a terrible job in Bavaria will stand in the way of serendipity and arboreal happiness. The job of the historian, and here I come to my second point, is to draw inferences from relics. We investigate something that has survived from the past and use our expertise in doing so to reach evidence-based conclusions. Rob, welcome. You're one of us. As a paleoclimatologist and dendrochronologist, you can draw on a worldwide army of collaborating witnesses. They are long-lived, don't change their mind in a hurry, and have memories that go back to the dawn of time. Year by year, they make an entry into their chronicle of the climatic and environmental context, and they share their life story with you because you have the key to unlock their code and translate it into answers to your questions. I wonder if it is your work with these records, Rob, that has contributed to you developing such a tolerant and appreciative attitude to the path through life of the crooked timber of humanity. I assume it must be the odd years, the strange patterns, the seemingly random disruptions, rather than the regular, steady uniformity that attracts the attention of the dendrochronologist and allows them to generate arguments and ultimately new insights. Rob, you've made a powerful and invigorating case for valuing and protecting the culture that allows human inquiry to flourish in the organic, serendipitous, and arboreally happy ways that you have laid out. The warnings you gave us at the end of your lecture have reminded us that this particular orchard needs tending and pruning too, lest bad academic practices and the effects of an unfriendly environment rob us of that which makes our scholarly lives rewarding, productive, and fun. In his poem, Delight in Disorder, the metaphysical poet Robert Herrick wrote in praise of what he called wild civility, and admitted that this state did more bewitch me than when art is too precise in every part. Dear Rob, for reminding us that in our art we need to mix a little wildness with civility in order to continue to bewitch ourselves and others, you have a heartfelt thanks. May you remain serendipitous and arboreally happy for many years to come. Thank you.